Now we'll be discussing spatial auditory attention. So auditory signals capture attention quickly. Visual stimuli are processed more efficiently if preceded by an auditory signal. So let me just highlight this. The slide investigates whether auditory signals are also benefit from priming by other auditory or visual stimuli. So the finding is there is no advantage in priming a location for an auditory stimulus. There is no advantage in priming a location for an auditory stimulus. Conclusion: prior knowledge of where an auditory signal will appear does not improve detection performance, though it may improve reaction time. So this slide it connects to cross-modal attention research, which explores how different sensory modalities, for example vision and hearing, interact. The lack of priming advantage for auditory stimuli suggests differences in how visual and auditory systems process spatial information. So priming is basically a phenomenon where prior exposure to a stimulus influences response to a subsequent stimulus. Now focused auditory attention and frequency selectivity by Bertram Scruff, S. Quigley, C. Aoki, N. Pichi, and A. Reed, 1987. So these are two graphs that are given. Range of detection of target tone is very small, auditory attention filter zoom length. So you might not understand anything from this, but we'll be discussing it in depth so that you can understand clearly. So the key points: experiment was that participants were given a cue followed by two signal intervals 1 and 2 and had to respond when they detected the target frequency. So there are two graphs: expected frequency, high accuracy; unexpected frequency, low accuracy. Finding was auditory attention is highly selective. Detection accuracy is very high for expected frequencies but drops for unexpected ones. Okay, so auditory attention is highly selective. Detection accuracy very high for expected frequencies but drops for unexpected ones. Contextual analysis supports the auditory attentional filter hypothesis. The zoom lens analogy: auditory attention focuses narrowly, enhancing processing of specific frequencies at the expense of others. Terminology: frequency selectivity, the ability to focus on specific sound frequencies while ignoring others. And zoom lens model, the idea that attention can be narrowly focused, high resolution, or widely spread, low resolution. Idea that attention can be narrowly focused, high resolution, or widely spread, low resolution. Alright. So range of auditory attentional filter: prior knowledge of intensities doesn't improve auditory detection. Auditory performance range from a narrow set of frequencies. If participants are trained to listen to 700 and 1600 Hz, we are good at detecting these extremes but not intermediate frequencies. Right? So key points: prior knowledge of sound intensities that does not necessarily improve auditory detection. Auditory perception is limited to specific frequency ranges. Trained participants in 600 Hz and 1600 Hz were good at detecting trained frequencies but poor at detecting intermediate frequencies, for example 800 or 1000 Hz. Now, the attentional filter is frequency specific. Attentional filter is frequency specific. Let me highlight that. Making people become selectively attuned to certain frequencies. Suggests limited generalization in auditory training. If trained at 600 Hz, performance at 800 does not necessarily improve. Right? Now, attentional filter is a cognitive mechanism that selects specific sensory inputs while ignoring others, and frequency selectivity, ability to differentiate between different sound frequencies. Okay, so let me remove this and this, because this is extra. Now, we'll be covering this in the next slide.